apparently. Well, the trouble is we're not supposed to have students in it because that's a FERPA violation.
Then why don't you put your podium in the middle?
You can put your podium here. Here's the podium. Okay.
Think that'll work? It's still going to be too short.
Did I?
Maybe that'll work.
You need it farther back.
Farther back?
Yeah.
Well, you be the...
It'll work itself out.
This stuff is so easy anyway, isn't it? For some of you, how many of you are so bored can't stand it?
I'm just not that smart.
Not bored? Is that my fault? It could be.
No, I think just reading the book, like, you
Yeah.
have to like focus so, I've had you, like, I'll be like, oh yeah, I get it. And then 2 sentences later, I'm like, I guess I don't. I don't know.
That's what happens with me.
Are you like that?
I have one student in this class who's on a deployment right now, and in fact, as far as I understand, won't be back for the year. And it turns out she doesn't have her book either. So, trying to explain things to her without the book. That's been difficult.
If you want to pass her my email address, I can scan pages and email them to her.
I could ask her if.
Yeah,
that would
and
be
that's what I'm
okay.
saying, like, don't pass me her email address, you can pass her mine. And then she can choose.
That's right, that would be true.
That way you wouldn't be breaking any rules.
That's important.
Yeah.
The reason the rules are there is somewhere along the way, someone figured out that we needed them. Okay, so that was the second quiz question. So there's multiple steps involved. One, translating what's obviously not really ordinary language arguments, but they're close. They're closer than anything else you'll see in the book. Right? People really don't talk like this when they're arguing, but nonetheless, you get the. I think you get the idea. Right. So if animals are not conscious or do not feel pain, then they do not have any rights. Animals do not have any rights. Animals do not feel pain. Thus, animals are not conscious. You might like the argument. You might like the statements and feel they're true. What's wrong here isn't the argument itself, it's the form of the argument is what's wrong. The form of the argument is bad. And you can see that because if you have this arrangement, you could see that you could end up with a false conclusion, but all true premises. It's an invalid argument. That was the exercise, is doing that. Okay. But you could also use them for seeing if they're consistent. You have a couple of good examples here. P or not Q, not P and not Q. That's page 376. First example, right? You build the truth table. So you have those two statements next to one another, and then you could go through building your truth table to see if both of them can be true. And they can. So that way you can easily see if statements are coherent, whether they're consistent. Remember I think we briefly did some that were inconsistent last time. And I think sometimes the way these words are used formally turns out to be counterintuitive to the way that a lot of the words are used in everyday speech. I remember doing the argument, your mother's says clean your room and then you can go out. If you clean your room, then you can go out. It turns out that if you use the formal logic to analyze that, so you basically just said you could go out. That's not really what Mom intended, I'm sure, right? So it's kind of annoying how formal logic shows us loopholes and problems that we have in our everyday speech. It's very annoying. Or you get the same thing when we start talking about quantification. Everyone's here, yay! Well, that's totally false, because there are people in India, there are people in Georgia, there are people on the moon. No, there aren't people on the moon. But it's clearly not the case that everyone's here.
I pick on my friend quite a bit for that. He said, does 99% of scientists say this, this, this? They ask every single scientist. Can't be true.
Well, can you get through?
Yes.
We're just trying to figure out a way to get this blackboard, well, it's not a blackboard anymore, into the...
Good.
It works. But the best way to go through this is step by step through the whole thing, and we don't really have time to do that this evening. But what I want to do is start talking about natural deduction. Another way of talking about natural deduction is to call it the propositional calculus. And the reason for it is, as you've seen with the truth tables, even with the shortened version of the truth table, it's quite tedious to go through a lengthy argument using truth tables in order to find out if it's valid or invalid. And by the way, even though we could find out if this is invalid by finding it wrong, it would require us to go through every possibility in order to make sure that it's actually a valid argument, to prove that it's a valid argument. So you'd have to check every single line, which would mean you'd have to build the entire truth table, right? Right. I mean, one line that demonstrates that it's invalid is sufficient to prove that it's invalid, obviously. But to prove that it's a valid argument, you'd have to go through every single line. And so it would be tedious, because we'd be looking at 1, 2, 3, 3. Still 3. That's 8 rows we'd have to do in order to check that. We'd have to check every single one. So that's rather tedious, and this isn't really that complex an argument. So it seems like we shouldn't have to go through that much effort in order to do it. Natural deduction enables us to do that. This is a system, a proof system. If you've done math proofs like that, you know that that's exactly what you could do. You could find the inferences that are valid, and then in order to check a more complex argument, just use the inferences you already know are valid and apply them to that argument until you can get to the conclusion. And if you get to the conclusion using just valid rules of inference, then, and this is actually proved, the argument is a valid argument. Right? So all we have to do is remember the inference rules, and remember we already did those. So we just have to start applying those. But instead of doing it across the way we do with truth tables, we'll do it instead numbered and going down the page instead. So, rules of inference. We already talked about those. We done modus ponens, right? Remember modus ponens, page 385. If P, then Q, P, therefore Q. Notice these, I'm sure you realize these are very simple argument forms, right? That's the goal. What we're looking at here are the simplest argument forms that are valid, right? So these aren't meant to be complex. what you do is you build more complex argument forms using these, right? But so modus ponens, if P then Q, P therefore Q, and you've got several examples of valid applications of modus ponens there at the bottom of the page, right? And that's page 385, right? You're all seeing what I'm looking at here. Now, the nice thing about the way the book points this out is when we say if P then Q, but P is the case, therefore Q, right? Notice what we're looking at is that particular thought pattern. But that thought pattern can be applied in ever increasingly complex situations. So when you look at the valid applications here, notice all three of them are way more than just if P then Q, right? Instead of if P then Q, I have in the first example, if R, then M or N. So in this case, R is in P's place, but for Q, I now have M or N, right? So what they're trying to point out to you is that Q is a placeholder, it's a variable for whatever is on the right side of a conditional statement. And that conditional statement can be as complex as anything, right? Second premise in the first example is R, which is what you have in the antecedent, right, of the conditional statement. So you do have that. Well, if that's the case, then we do have what's on the right, M or N. There it is. Get through. You can push that back. Nicely done. You know, one of the questions in the crossword puzzle the other day was the mansion, the guy that's the Batman, what's his name? His mansion, you know, a feature of his mansion, and it was just perfect for Bat Cave. I thought, yay, no, it was Bat Pole. Just so annoying. Just, sorry. But you have the Bat sweatshirt on,
Yeah,
so I figured you would enjoy that.
I did. Thank you.
Okay. Okay. A second example, we're on page 385 of a valid application of modus ponens. Notice it's even more complex, right? So on the left side of the conditional statement, you have P and Q, then G and not D. Right? Or you could throw anything in there because what they're trying to do is just show you these can be more and more complex looking. But the basic ingredient here is that you have a conditional statement. The second premise is the antecedent of that conditional statement, and the conclusion is the consequent of that conditional statement. Notice you could do that however complex it gets, right? We're referring to those as substitution instances, right? Notice there's errors you can make, and so they show you an example of two errors on page 386. So if you have as your first premise either L, if L then Q, or R or S, then you have L, and the conclusion is Q. Notice what they've done is they've taken the conditional statement out of a more compound statement there. And you can't do that. You can't just take a conditional statement out of a more complex statement and apply modus ponens to it, regardless of what happens to the rest of it. So you can't do that. That's an error. So inference rules have to be applied to the entire step, right? Not to just part of the step. In this particular case, they're only applying the inference rule to part of the step because it's a disjunct, They're just applying it to the left side of the disjunct. You cannot do that. Same thing with the second example. They have another variant of wrongness. If that's, I don't know how you want to express that, but that's just totally wrong in the second cant. Okay, further down the page, they also point out, again, the fallacy of affirming the consequent. If you have the inference, if P then Q, well, I have Q, so I must have P. Notice that there's at least one instance where that can be demonstrated as invalid. So that's a fallacy. So that's one inference rule, modus ponens. And notice it's QP, therefore Q, that's called MP for modus ponens. Second one, modus tollens, we've done this one. Modus tollens goes if P then Q, not the case Q, therefore not the case P. So again, this is a conditional statement. If I have a conditional statement, if I do not have the consequent, then I must not have the antecedent. So that is a valid inference, right? If P then Q, but I don't have Q. So then I don't have P. Be a example of this. If you have a top secret clearance, you can be informed of all the White House information. You can't be informed of the White House information, so you must not have a top secret clearance. Sorry, it's just true. I can't ask you how many of you have had top secret clearances. You'd all know the answer to that. So, substitute for this. Valid applications of this. If H, then T or N. But it's not the case that T or N, so it's not the case that H. It's in the middle of page 387. Is this a weird inference for folks? Modus ponens seems pretty easy. Modus tollens, is that a little harder to wrap your finger around? Okay. Another example, if G and D, then C, but it's not the case that C, so it must not be the case that G and D. Notice you could make it even more complex. It's not the case F or D. What are they doing here? Ah, okay, this is fun. Okay, so notice if your modus tollens goes if P then Q, not the case Q, therefore not the case P. Well, what if I started off by saying not the case Q, but if P then Q, then not the case P? Right? Well, that's what they've done in this third case. Notice they've given you the not Q part as the first premise. Doesn't make any difference. Your argument doesn't have to follow the actual sequence as long as it includes all of the premises. You still end up with the same conclusion. So that's what they're showing you in the third example here. Did they do that on the first one?
Yeah,
They did?
it's the third example.
Okay. I skipped that one. But that's good that they put that there. We do have misapplications of modus tollens, and I think I mentioned that before. That's denying the antecedent. So you go if P then Q, but not the case P. Oh, well then, not the case Q. There's at least one set of possibilities where you could actually have the premise is true and the conclusion is still false. So that is an invalid argument.
Can you give us an example of that? Because using the previous example where you were saying if you don't have a top secret clearance, then you don't have access to the files of the White House. If you were to use that statement here, it wouldn't be false.
I won. So this is Modus Tollens.
Okay.
So that's a good argument. That's a valid argument. But what I want is the fallacies to all go P then Q, that instead of denying the consequent, now we're denying the antecedent and figuring, oh, that shows that we can't have Q. Intuitively, that feels right, doesn't it? Because you're saying, well, if the moon is made out of green cheese, then the Pietà is a beautiful statue. It's not the case that the moon is made out of green cheese. So therefore, it's not the case that the Pietà is a beautiful statue. No, Pietà is like officially the description of what a beautiful statue is. Even if a nutcase takes a hammer to its nose. They did fix it. The Pietà, Michelangelo. Mary with Jesus draped over her after she was taken down off the cross.
Actually, no, I took an art appreciation class right there. I'm sure we talked about it. That's awesome. But I don't remember. And she was all about that kind of stuff.
I gotta get my medicine. No. Just kidding.
I don't really have much of a memory, so.
You said that last week.
Probably.
Sure? Just kidding. There's a couple of people have said this, that you guys are much smarter because of that Flynn effect, but you're ahistorical. You have the lack of the history, the data, and everything. So I said, I said to my daughter, does it seem to you like you meet a lot of people that are ahistorical? She said, yes. And she paused a moment and she said, when did that happen? Yeah. And we just both laughed, because that's a joke.
There's a video on Twitter right now where it has the world map, but like Europe's on this side and then Alaska's like this, so it's like mirrored than what you normally see. And it they probably interviewed 100 people, but they chose the 3 dumbest to make the video about. And the thing was, I was point on the map, one country on this thing, and it's they would point to the Europe region and be like, Europe, and they'd be like, nope, that's not. Not a country, it's a continent. And then they'd be like,
did Sarah Palin get any of them right?
Or they'd be like, okay, let me try again. And then they'd point to Africa, and the interviewer was just because these people were so dumb. Someone was like, aren't they supposed to teach this to you in high school? Oh, it's so
You
funny.
can Google it.
Yeah.
I used to be appalled at the Jay Leno jaywalking sketches that he used to do. He used to just go outside the studio with a mic and he'd ask people questions that you would think everybody knew. When did Columbus sail the ocean blue? All that kind of stuff. So I thought people aren't really like that. So I started asking those questions in my classes. And yes, they are. When I ask people when did Columbus sail the, his first visit to the so-called New World, I had people saying 1968.
Wow.
which was, you know,
The height of the
when I was
Spanish
in
Empire.
high school, you know.
That's impressive.
So, you know, that's, it's like,
To be fair, that was the height of the Spanish Armada, so
1968,
That's a joke too.
that was,
Bad one.
all right, so misapplication of modus tollens, that's different than the fallacy of denying the antecedent. This is the fallacy of denying the antecedent. So and the situation where this would obviously be fallacious would be like that example of where the Pietà is beautiful, but you conclude that it's not because the moon is not made out of green cheese, right? Blue cheese? Orange cheese.
Cheese.
Cheese of some sort.
So you can utilize that or not use the fallacy, but you can confirm this fallacy even with an antecedent and a consequence that don't even actually have any relation to each other. And that's how
Right.
you would
In
utilize this
fact,
fallacy.
you'll notice the examples he tends to use. This is true of all of the logic books I've ever seen. Really, is they try to avoid causal relationships because they want to stress the fact that no, the premises don't have to have any real relationship. It's just made up stuff for logic class,
Hmm.
which you might want to get into, like, well, what about causality? You know, is
Right.
causality, isn't that something that logic ought to be dealing with, is causality? Because that would seem to make a big difference.
Well, people don't normally talk that way. They just say something random like, "Hey, there's a chair. If there's a chair here, then there's a red light outside." You know,
Right,
like
right.
it doesn't make any sense. Like, why would that be affecting a red light that's outside?
Or why would you get that kind of crap in a logic class?
Yeah. I'm just trying to
And
see
they
how I
do,
would be able
and
to
they do.
utilize
That's,
this in an
you know, because they want to make sure you're not mixing causality with conditional statements. You know. But there's lots of room for wondering why logic is the way it is and thinking that we ought to fix stuff like that. Logic ought to be more practical, shouldn't it? Duh,
I would think
right?
so.
You would think so.
Hmm.
I don't know. Hypothetical syllogism, we talked about that. That's kind of, that's the one I pointed out that if you, I won't keep putting these up on the board. Hypothetical syllogism is the one where really, if you think about the way Aristotle thought all knowledge was based, really, was by saying if this is in here and this is in here, then this is in there. It's pretty obvious, right? And that turns out to be the thought pattern behind Barbara, the divine argument form of Aristotle's syllogisms, but it's also a hypothetical syllogism. If P then Q, if Q then R, well then if P then R. And if you flip the hypothetical syllogism's premises around, you'll see it's the same as Barbara, A1. So it seems like the divine argument form, and you can just see, well, yeah, if everything that's in here is in here, and everything that's in here is in here, then these have to be in here. Human thinking gets no more basic than that, no more successful than that. That's like the epitome of good reason. And the way science is really supposed to work, if you think about it. At least in the European languages. And I don't know what knowledge is outside of that area. Because I don't know how those languages do what they do. So the first, the last one is disjunctive syllogism, which is on the bottom of page 388. P or Q, it's absolutely correct that you either have P or you have Q. Oh, but I don't have P, then you must have Q. And vice versa, by the way, which they give you, actually, right? Notice both of them are right there. Trouble with programming a computer is if you have variance on an inference rule that you're allowing the computer to do, but you don't neglect to give it one, then the computer can't do that, right? It only can do what you tell it to do. In this case, they're showing you both of them, so you being the computer, you could do both. Okay, so applying the rules. So page 389, this is the first case where what he'll do is he'll number the steps. So we've got an argument. Notice the first premise is if S then P. And instead of going across the top here, we're just going to keep going down like this and say S. So this is modus ponens, my conclusion P, right? But now the question is, how can you demonstrate that this is a valid argument using this system? Well, I will have to give my justification here and come down and say, well, from this I can get P, and how did I get it? I get it from steps 1 and 2. Sorry for my frilly 2. And how did I get it? Notice I can just abbreviate modus ponens. So that's the format for this propositional calculus. We'll just do our proofs by saying, okay, so here's my argument. I end with the premises by saying slash, here's the conclusion I'm trying to get. And then I will build the rest of this to try to show how I could get this conclusion out of this. This first one, of course, is pretty easy. It's just one inference rule, modus ponens. But notice, we'll show the sequence, which steps that I used, and then the inference rule, the abbreviation for it. Right? We've got 8. So at this point, we've got 8 different inference rules we could use. Right? So remember when I said that my next test will be a series of problems from that one exercise. This is the format you'll be using to do that. Okay. Page 391, number 8. I wrote quiz there. Did I give you that quiz? No. So that'll be quiz 1 for tonight.
Page 390 what?
391.
391. Great.
Number 8. For the folks, is that still running, hopefully? I don't know when the battery runs out. I'll write this one down for those folks. Number 8. Premise 1. If P then Q, then R then S. 2. But it's not the case if R then S. Therefore, it's not the case if P then Q. The next step. It's not the case if P then Q. So here, all I have to do is write out, essentially, how I would have gotten this. Notice that this is a conditional statement. If P, then Q. Notice I'm just using modus ponens to explain that. Right? Obviously, there's more complex things here than P, more complex things here than Q, but notice it's a conditional statement. Whoa, that's not modus ponens though, it's the negation of this, so that's modus tollens. And that's exactly how you would basically solve this. Should I go ahead and do that? I'll just do it. 1, 2, modus tollens. So there's your quiz answer, actually. Isn't that hateful? This class is just so easy, isn't it?
Something like that.
You could always flip it over and do it backwards. That would make it more difficult. Guess it would be upside down. I'd be standing on the floor upside down. I tried to get tired enough today to take a nap so that I wouldn't get tired in the middle of class. Didn't work. I couldn't get tired today. So I even ate a big sandwich. Didn't help. Sorry about that. If push comes to shove, what I could do is just take a nap roughly around 7:30 and then maybe have a little milk and cookies first. So tactics and strategy. With regard to the first 4 implication rules, tactics are the maneuvers you make. You guys have heard of Heimlich, the Heimlich maneuver?
It's not called that anymore.
Really?
Isn't?
Nope.
What is it now?
Abdominal thrust maneuver.
Abdominal thrust.
Is that a politically correct thing?
Yes.
No, it has to do with the fact that people were doing it wrong and blaming it on the Heimlich maneuver. So the family was getting some flack about it, and I mean the guy's been dead for like years, but like the family was getting flack about it. So
What the hell is wrong
The
with
They decided
abdominal
to-
thrust.
relinquish
Maneuver.
all rights to the maneuver.
Well, I'm never going to try it ever again. It's disgusting.
Just disgusting.
Someone's choking out of luck.
Oh. So tactics and strategy. Use small scale maneuvers, inch by inch, right? Strategies, look at the overall goal. As things get more complex, you look at the conclusion and you try to figure, how on earth can I get that out of this argument? Where does that conclusion come from? So let's do some on page 398. Use the first 4 implication rules to complete the proofs. And in this first section, all we have to do is provide the justification for each step. Right? They give us one. In the first example, step 1, it's not the case P and Q. Step 2, it's not the case, or rather, I should read, if it's not the case R and S, then L and not Q. 3, if R and S, then P and Q. And the conclusion is L and not Q. So the question you have then is, well, how out of these premises do you get the conclusion L and not Q? Is it there? Well, actually it is. It's there perfectly as the consequent of the conditional statement number 2, right? And if I look at that and I think, oh, how can I get that out of there? Well, modus ponens will let me take it out of there, provided I have the antecedent, not the case R and S. But where can I get that? I don't have that. I do have R and S as the antecedent of a conditional statement. Aha! But I do have the negation of the consequent of that conditional statement. So first I use modus tollens on statement 3 using statement 1. So 1 and 3, right? Modus tollens will give me not the case R and S, and that is the antecedent of the conditional statement number 2, which will give me L and not Q modus ponens. So those are the two steps with justifications. Do you see it?
No.
No. Okay. Well, let me sorry.
Always
I'll
try.
do it step by step.
Where are you, Dr. Jameson?
Which?
Where are you?
Where am I?
Yeah.
In
In the text.
Well,
Where were you
In
from
the text.
What question, yeah, what?
398. Ah, yeah. Being on the right page can help.
Number,
1.
there we go.
So, here, I'll write, this is what's in the book, right? We have, this is, so that 1 stands for problem 1. And the exercises, well, that's confusing, right? And then immediately you have, okay, well, 1, that's step 1, right? But is also a premise. So in this particular case, the premise 1 is not the case P and Q. Step 2, not the case R and S. And if this, then L and not Q. Step 3, R and S, then P and Q. The conclusion of the argument is L and not Q. You could imagine this being an argument, right? So P equals fetus is a person. Q is women have rights over their bodies. I'm just making this up as it goes, so.
Alright.
Not R, well, let's see, R would be, R could be, religious people are pro-life. S equals atheists hate everybody. This is just supposed to be funny. L, what's L? L stands for living things are green. Need anything else? That's it. Okay. So this argument is, it's not the case that a fetus is a person and women have rights over their bodies. Second premise, if it's not the case that religious people are pro-life and atheists hate everybody, then living things are green, and it's not the case that women have rights over their bodies. Premise 3, right? You get the idea. You could, look at this as a full-fledged argument, right? Religious people, so if religious people are pro-life and atheists hate everybody, then a fetus is a person and women have rights over their bodies. Therefore, my conclusion, right, living things are green, and it's not the case that women have rights over their bodies. So, whatever, I'm just using abbreviations, throw that in there. But you can imagine it's a full-fledged argument. Of course, that's not really the way people really speak either. You'd have to extend it and make it more complex than that. Instead of green, they might be aquamarine, something of that sort. Okay, so now what am I supposed to do? Next step. So this is problem one. They're actually giving us this answer, right? So what they say is, okay, so at this point, this is what the problem is, right? So from this point on now, I'm now proving that this is a valid argument by using inference rules. So what I'm going to try to do is figure out how could I get this out of this argument. And notice I'm looking at this, and I see it right here, right? So I can get this out of that argument if I could get this out of here. The trouble is, this is part of a complex statement here. This is a conditional statement. The only way I could get this out of here is if I have modus tollens, which would actually not get it out of here. Really, if I have modus ponens and I had this, then this could come out. Because if I had this part, then I know I have this, and I'm all set. Can I find this in the premise? No, that's not there. Well, this looks like it, but the only problem is this is negated and this is not. This is affirmative. Well, if this is affirmative, how could I get this to be negative? Well, this is a conditional statement, and this part is right here, but notice this is negated, this is affirmative. Well, if that's the case, then I can use this and this using the inference modus tollens to get not the case R and S. How did I get that? I got that from step 1 and step 3, modus tollens. Valid inference rule. So if I have these two statements, I know I also have this. Since I have this, and this is the first part of this compound statement, the antecedent, this is modus ponens, and I now know I have this. How did I get it? I got it from, now notice, this is one of the steps involved. This is step 4 and step 2. So 2 and 4, modus ponens. And I'm done. That's exactly what they have in the book. See how I did it?
I saw how you did it. Don't understand.
So if you were to take, trying to understand modus tollens, it's P then Q, not Q, then not P.
Right.
And that's how you get, that's how you're using 1 and 3, because 3 is the P then Q, right? Looking at the parentheses,
Exactly.
you have P then Q. Well, you have not Q, so then therefore you have not P, which is the parentheses of R and S.
Right. Right.
And then using that along with the second statement, you're using if the modus ponens, which says if P then Q, and you have Q, then you have P. And that's it. Okay, I get it.
Little steps. We only have, these are the only inference rules we as human beings have to think correctly. When we are thinking in more complex ways, we're using these little incremental steps together in more and more compound ways, right? But we don't we don't get more inferences than this. This is it. Feels like we're much more complex than that. But remember, we only have really 3 logical operators, and, or, and not. That's it. But then we can combine them and get things like horseshoes and things of that sort, right? But when we're thinking in terms of valid argument forms, these are all of them right there. And in fact, the most complex one bugs the heck out of me because it really looks like it's 2 modus ponens twice. So it seems like we ought to be able to do away with that one and just have 7. But can't figure that one out, right? And so that's all of the thought patterns we have that are good thought, good rational thinking. Outside of that, you're wrong. You're making a mistake. It's invalid. Right? Or, of course, if you combine these, and that's what we're doing. We're looking at finding really complex arguments, and then taking all of these inference rules and applying them. And this is one of those things that have been proved, that if you're only applying valid inference forms to the proof, and you get the conclusion that it itself is valid. Whereas it's a whole other thing if it turns out that the argument isn't valid. If you keep trying and trying and trying and you don't get the answer showing that it's a valid argument, you might think, well, I guess it's not valid. But actually you can't take that shortcut. You have to build a truth table and go all the way through it to demonstrate that it's invalid. So we do have some interesting problems too, because if you end up with a contradiction in your argument, you will never have a way of showing that all of the premises are true. So you won't officially be able to prove that an argument that has a contradiction in it is invalid. That's annoying, because you feel like, well, if it's a contradiction, it's definitely not a good argument, because that could prove that the moon is made out of green cheese, which we know it isn't. Right? So I suppose one of the things you can get out of taking a logic course is you realize that human beings are in a world of hurt. We don't know what the heck we're doing. In fact, we know for sure we don't know what the heck we're doing. Does that help? It's one of the interesting things, that they say that the wiser you get, the more you don't know. So that's kind of embarrassing. Then there's the Dunning, what's it called? The Dunning-Kruger effect, is it? Anybody have the internet on? What's the Dunning-Kruger effect? It's where you don't realize that you don't have the skill to know how to do something. You don't know what you don't know. Kruger, Dunning-Kruger effect. That's, if you don't know the answer, you don't even know how it is that you, I forget. You get the idea. We're stuck. Okay. Let me do another one, because this seems to be working pretty well. Number 2, same page. This is just number 2. Step 1. If P then Q, 2. If R then P. Step it's not the case Q. Therefore, it's not the case R. Notice this is not given in the book, the answer. So I will have to invent step 4. What do I want to do? I want to find not R. How do I get not R out of this? Well, my premises, I have if P then Q, if R then P. So here's R. Notice it's not the case that it's not R, it's affirmative R, right? So how would I get negative, not the case R out of there? What was the person thinking when they were arguing this? I mean, they're trying to tell me that it's not the case that R. It's not the case that the redwood trees are healthy or whatever, right? Well, if the redwood trees are healthy, then this is prime forest or something, right? But he's concluding it's not the case that the redwoods are healthy, right? But if it's prime forest, then it's a happy place. But it's not a happy place. So it's not a prime forest. If it's not a prime forest, then the redwoods are not healthy. So what he's actually trying to do is convince me that this is the case. Is it valid? Where does that come from? Well, I have not Q. Not Q gives me not P. And that's modus tollens on 1 and 3.
And then you have not R because of modus tollens 2 with 2 and 4.
So that's his thought pattern. And that's valid. I mean, I still have to go and analyze his statements. Are his statements true, right? But at least the argument he's giving me is a valid argument. Notice I just totally made up the redwood thing. It's not. If you think about it, there's not a whole heck of a lot of valid argument forms that we use. I mean, you can imagine divorce lawyers using this in court to explain why he's such an idiot, you know, or something, or whatever. So that's 2. You see the pattern? We get the argument, the conclusion, and then you have to figure out the rest. And by the way, in this particular case, there's only 4 argument forms we're allowed to use in this exercise: modus ponens, modus tollens, hypothetical syllogism, and disjunctive syllogism. So right now we've only got 4. Notice altogether we have 8 of these, plus we also have replacement rules. And what we're going to be doing is building up our menu, so to speak, so that we have all of these at our disposal, so the arguments will get more and more complex, so that by, is it next class? Yes, next class, we'll do the test, right? Because we only have 1 class after that. Dance. Through the rest of the chapters. So some of them are tap dancing, some ballet. I'll do 1 more from this chapter here in this section. How about 12?
We're looking at the 398, right? Or 399?
399, 12. So not the case. P P, and S. Step 2. Not the case R. Step 3. If not the case P, then P or if Q, then R. If P, then P and S. And the conclusion is not the case Q. So not the case Q. This argument is all aimed at convincing me that not Q. Where does not Q show up? Well, here's Q. It's the only place where Q shows up. Of course, it's not Q in this case, it's affirmative Q. It's also attached in 2 places. It's the antecedent of a conditional statement, and that whole thing is in a disjunct here, and oof, it's in a conditional statement itself. So there's no way that this is just free to negate and take out of there. Somehow we have to get this whole thing here how are we going to do it?
I have a question.
Yes.
Just, so, the other examples that we did, they had the 3, and then the answers were
The justification.
just the justifications. There was 2. Is there a way to know that you're doing the right amount of justifications? Does that make sense? Is there
Not really.
a, okay.
In the exercises, they will tell you, okay, use 3 steps. You can do it in 3 steps, or use 2 steps, or
But there's not some kind of, like, this has
but
4, so
actually,
there should be, like,
as long as you're using the inference rules correctly, you're not making a mistake. In fact, the more complex ones, you can start off and just keep going and going, but that's not getting the answer. So try some other way. You can keep going, and that's okay. And in fact, what I usually will do in the test is give you points for all the correct inference rules you use, even if you don't get to the answer. So you might not get all the points, but you can still get most of them, even if you end up not getting to on the hard ones. You can imagine these are going to get more and more difficult. Actually, in a way, it's more and more fun if you like that kind of stuff. So that's I mean, it's easy. Bloop, I get a little trout. Oh, that was fun. All afternoon, and in comes a great big floppy fish. That was more fun. But you know what? That was 2 heart attacks ago. I have trouble with halibut just getting the weight up that I dropped. I'm almost always convinced that I've already caught a fish, and when I pull it up, all I've got is the weight that I used to get it 250 feet down anyway. So, you've gone fishing for halibut, right?
Not specifically. I worked commercial fishing for a while. We caught quite a bit of halibut, but
I even went fishing for halibut from the Coast Guard cutter when I was out. That was pretty impressive. But that's quite a ship. Can you imagine? Well,
I've caught mahi from a submarine before. It's pretty cool.
you've caught, wait a minute,
Mahi.
you've caught fish from a submarine. Okay.
Yeah.
It was on top of the surface though.
Yeah. Although
Okay. I'm still impressed with the guys that live 500 feet down. That's
no, I've gotten out of a submarine while it was underwater before too.
odd. I've never gotten on a submarine that was underwater.
I get into a submarine.
I've toured, you know, like the ones in San Francisco at the, you know, the
But it's like.
dock.
Get onto a submarine.
Okay, so how do I get not the case R, Q out of here? It's gotta come from here. But somehow I've gotta get this negated.
Yeah.
I'm obviously going to have to get not the case P.
And you have to reverse P and S.
So I'm looking here, if I get not the case P, that's gonna give me this. Can I get not the case P out of here? This is if P, then P and S, but this is not the case P and S, which tells me that modus tollens will give me not the case P. How did I get that? From 4 and 1. So since if P then P and S, but it's not the case P and S, then it's not the case P. Modus tollens. Not the case P is the antecedent of this, which means step 6, that I have P or if Q then R. How did I get that? This is, I have not P, right? Not P is the antecedent here, so that's modus ponens,
With 3 and 5.
3 and 5. Yes? Step 7. Well, we haven't used disjunctive syllogism yet, but remember disjunctive syllogism goes either P or Q, but not the case P, therefore Q. Because if you're absolutely sure you either have a radio or you have a television. Oh, I don't have the radio with me. I do, so I must have the television or I lied here, right? So disjunctive syllogism works. And what do I have here? I have a disjunct, this or this.
So you have Q and R, Q then R because you already don't have P.
Exactly. So I have if Q then R. And that's disjunctive syllogism from
P's not R.
6
Which
and
means
5.
yeah. Because you're taking it out of bracket.
And I have not R,
You're finally pulling it out of that. You're pulling it out of the area.
which means I have not Q, modus ponens, or I'm sorry, modus tollens, 7 and 2.
You just so that way you can understand the steps that you want.
Isn't this more fun than making yogurt?
Well, I've never made yogurt, so I don't really know.
I have made yogurt, and that is a lot more fun than this. I really have.
But you're just sitting there while it's warming up.
That might be, that might be the point.
Let me ask this another question. While you're going through this, is it ever helpful to cross things out? You know, like how you do in math, you're like, okay.
In your mind, if you like.
So no.
So no, it's not.
So you want to, well, I suppose you could, just so long as you could still see where you got it from. Because what I'm gonna do is grade this step, this step, this step, this step. So if you've crossed them all out, I'm like,
Yeah.
what did she have there? But in your mind, you could like, use that one. But the thing is, you can use each of these more than once. Just like if it's a really complex proof, and I've used this to get something here, but later on, I might go back and use that again. So if in your mind you're crossing it out because, oh, I've used it. No, these are all available to you. So we'll do another one from the same page. How about 15? So in this argument, the conclusion is R. Where is there an R? Well, there's an R here. And there's an R here. It's actually, it looks like it's the same because it's if Q then R. But the easiest place to get anything out of here is right here, because I have P. If P, then if Q, then R. Well, modus ponens will give me if Q, then R.
Mm-hmm. 1 and 3.
Modus ponens. And that comes from 3 and 1. Well, if Q then R is the antecedent of this conditional statement, which means I have if Q then Q. Again, modus ponens from 2 and 4.
Then you get Q.
Since I have P, then I have Q. Modus ponens. So notice I used 1 twice so far. So I have Q, and if Q then R, so I end up with R. Again, modus ponens from 4 and 6. we're getting not P out of this argument. Well, one of the argument forms we haven't used yet is if P then Q,
And Q and R,
and if Q then R,
then PR.
therefore if P then R, right? Since I have if P then R, and that's the antecedent of this premise here, if P then R, then
you can say
R then Q, I have if R then Q, modus ponens from 3 and 2. And if R then Q, does that give me anything?
Excuse me, how did Q come from line 2? R is 2, Q is 3, okay.
So if P then R, that's a whole premise,
Right.
and that's given.
Yeah.
But in this statement, it's the conditional, so it's the antecedent of this conditional. If P then R then Q. Well, since I do have if P then R, then I do have R then Q.
I see.
And that's modus ponens.
I see.
And if I have P, then R, and if I have R, then I have Q, then I have if P, then Q.
Hypothetical
P then
solution.
Q, Q then R, Q then R. In this case, I'm going if P then R, if R then Q, so I'm going if P then Q. Hypothetical syllogism.
It's 2 and 5.
Using 2 and 5.
Then you can say that you have R then S because of modus ponens with 4 and 6.
Yep. Modus ponens. 4 and 6. This is the antecedent here, so I have a farther. P then R, and R then S,
And you have P then S.
P then S. Hypothetical syllogism, 2
There is a P
and 7.
Then you have not Q because of modus ponens with 1 and 8.
That's right. Not Q, modus ponens, 1 and 8.
And then you have not P because of modus tollens with 6 and 9.
that's what we were trying to get. It's helpful when some of you are way smarter than me. You could actually have taken longer steps, could have made other guesses, but as long as you're using inference rules correctly, that's not wrong. And half of the way we were going, I had no clue where that was going to take us. It was just performing the obvious relationships that were coming out of it. Cindy, do you think this is more fun than making yogurt?
I actually understand this part.
Cool. Have you ever made yogurt?
Have you ever made ice cream?
Yes. What a dismal failure that was.
With
You
an ice
had the
cream
machine you
churner?
put in the freezer and you plug it in and so the cord's coming out of it.
Did you do it with an ice cream churner, or did you do the weird?
No, we never did that. We
No.
cheated. And the machine was crappy. Way cheaper just to stop by McDonald's and get an ice cream.
It's like 50 cents.
The only thing is my St. Bernard will pick the ice cream cone up, take it somewhere in the van, and then eat it on the floor, and that makes a mess. But she likes vanilla ice cream.
My dog will eat anything but kale.
Anything like kale?
Anything but she hates kale, but she'll literally eat like bugs. One time she dropped a dead rat in front of my face while I was sleeping. That was
You
fun.
said a cat or a dog?
Oh no, it was a dog.
It was a dog.
She like licks the wall too.
Okay.
She's weird.
By the way, notice at the end of this exercise, there's some word problems. So for example, if my son drinks 3 sodas, then if he eats some chocolate, then he gets hyper. If he gets excited, then my son drinks 3 sodas. Furthermore, my son is excited. Or he either drinks 3 sodas or he eats some chocolate. But it is not the case that if he eats some chocolate, then he gets hyper. We can conclude that he eats some chocolate.
Oh, good God. I won't put words into this. Letters is fine.
That person's going to raise a really weird child. And a lot of chocolate will be involved, I can tell you that.
Are we going to be having word problems in the test?
No.
Oh,
Thank goodness.
Thank you.
But it's important to see that, you know, we're playing with P's and Q's and stuff. And I know you've probably already wondered, you know, does this have anything to do with the old line, mind your P's and Q's? Right?
7 has a lot leading up to it. 7 on the page.
Either I am, you mean that one?
Yeah.
Either I am going to the movie or I am studying for the exam. If I study for the exam, then I will not fail the course. But I either fail the course or I will graduate on time. I'm not going to the movie, hence I will graduate on time.
Oh, I can get that.
Good thing she picked the right.
I would go to the movie myself. But then I'm not interested in graduating anytime soon. 'Cause my next graduation is called death.
Fair enough.
Not interested in that big graduation in the sky. Not yet. Still too many jokes to tell. Carpe hilaritatum. Okay. But yeah, so you could see that we're playing with mind your P's and Q's, which, by the way, no one really knows the origin of that or what it meant. Does it mean mind your pints and quarts? You've heard that? I don't know.
I used to know this.
But it could also mean be logical. You know, use valid arguments. So implication rules, number 2. In other words, we've just done the first 4. What about the rest of them? Well, the rest of them are somewhat easier. Simplification. Remember, that one's the one I said was going to knock your socks off.
Still wearing socks.
Once I said that, I think it was the back row completely lost it last week. As you were expecting somebody to lose their socks. And I don't know. So P and Q, therefore P. And by the way, Q. I've got both the magic marker and the cap. And I've got the magic marker. Or the cap. Either way. Simplification. Notice there's valid applications of that, and notice it's just an example of having more and more complex examples of it. But when you get right down to it, as long as what you're looking at is a conjunction, a left and a right, with a dot operator, you can take either side out. Simplification. But notice the misapplication. If what you have is not a dot operator, but something like a disjunct, you can't just take stuff out of that. The main operator has power over it, and you can't just ignore it, right?
Can you call that an oversimplification?
I suppose you could. Could be an undersimplification, too. Conjunction? Well, I'm thinking misapplication, you know. If Russia is our friend and the European nations are our foe, or if Russia tells me they like me, then I'm silly. I'm a silly person, right? If Russia says they like me, then I'm a silly person, right?
Does that mean?
So it must be that.
So if Russia likes you, does that mean every single individual person inside Russia?
All of them, yes.
All of Russia, Siberia,
Yes. Каждый, бабушка, etc.
Babushka.
Everybody.
Меня зовут.
Babushka. Where did we get? But what did you say?
Babushka?
Babushka.
Babushka.
Grandmother.
It's,
No, that's
there's an
babushka.
awful. You know, there's no Moscow in Russia. There's a Moscow in Pennsylvania. There's one in Idaho, but in Russia there's a Moskva, which is totally different. It's not my fault. It's just weird where we get babushka, babushka. It's different. I don't know. We had one speaker from Leningrad. Leningrad is now Petersburg again, but not St. Petersburg. It's just Petersburg without the Saint.
St. Petersburg.
Is it still St. Petersburg?
I don't know anymore.
I dated a girl from there.
But the one, Mr. Rudnick, was from Leningrad, and so it was great because his accent was so different than all the other ones who were from Moscow. And what was neat was he ended up being the Bort engineer in 2010, the movie, the sequel to 2001: A Space Odyssey. One of my teachers from Monterey ended up being the Bort engineer. So it was so neat listening to him count because it reminded me of school days, you know, as he was talking about the craft coming closer and closer to the moon. You know, it's just neat. Oh well. He was also in Moscow on the Hudson, which was the movie with
Robin Williams, right?
Robin Williams. Yeah, he was the tall, funny guy. At a Dick and Din, tall and short guy. Yeah, he was the tall. Should we take a break? Okay, let's take a break. Battery.